Hello everyone. Today we will discuss the question and solutions of recently conducted JEE Mains examination. We will discuss the physics part and I have taken the shift 1 question paper of 29th January. We will discuss all the questions, all the 25 questions of physics section in details. As we discuss the questions in details, my request to all the students would be please sit down with pen and paper and then you watch the video. As soon as each question comes in front of you, please pause the video, try all the questions or each questions by your own first, and then only you resume the video and then you watch the detailed solution. If you exercise this practice, this will not only increase your confidence, but this will also increase the proclivity to solve the questions in general. I think this discussion will be helpful not only for upcoming JEE Mains examination but also for NEET aspirants. So this is the first question. The first question is assertion reason question. Whenever assertion reason question is given in front of you, the first step would be to read both the statements correctly. And when you read both the statement, please identify whether both the statements are correct or not. If both the statements are correct, then next step would be please try to relate the reason given with the assertion, whether it supports or not. This is the correct way to approach the assertion reason question. Now let's attempt this question. Well, in this question is basically from alternating current chapter and it talks about mercury bulb and chalk. Here mercury bulb is acting as a resistance and a chalk is acting as an inductor. Okay. The first statement given talks about the situation where a mercury bulb has to be connected with a chalk coil so that the mercury bulb can be prevented from damaging. Okay, this statement is correct, right? Let's read the next statement. The next statement tells that when you connect the chalk in series with the mercury bulb, then the voltage across the mercury bulb will be reduced by this factor. Okay, and this statement is also correct. And this reason is successfully supporting the assertion. Let me explain this with the help of the circuit diagram. Let's say this is the chalk, the inductor, and let's say this is the mercury bulb. Okay. Now every bulb will come with some rating. Okay, the specified voltage and specified current or power, right? Therefore, a particular bulb cannot be exposed to the voltage directly. Okay, because the voltage can be anything. Therefore, before connecting the mercury bulb directly to the AC voltage or AC source, if we connect one chalk in series, then what will happen? We know that electric components connected in series can divide the voltage. Okay, therefore voltage across the bulb, this bulb can be reduced. Okay, and this way the mercury bulb can be protected. Therefore reason is successfully supporting the assertion. Therefore both are correct and reason is giving the correct explanation. So option 3 is the correct one. Now let's move to the next question. Now this question belongs to projectile motion mechanics. It talks about two projectiles and both the projectiles are projected with same velocity but two different angles, 45 minus alpha and 45 plus alpha, and both are projected with the ground at this angle, and we are supposed to calculate the ratio of their maximum height. Okay. Now here in this question we can assume that the alpha given is less than 45 degree. Okay. Now let's say this is the first angle, 45 degree minus alpha, and this is the first projectile. Okay. The maximum height that it can attain is equal to h1. Then the second projectile is projected with angle 45 plus alpha, and let's say the height is equal to h2, and we are supposed to calculate this ratio h1 divided by h2. Well, we can see from the diagram that since for the first projectile angle is less and therefore the h1 will be less, so numerator will be less and denominator will be more. If you look at the options, option 1 and option 3, these two options are satisfying the criteria where numerator value is less and denominator is more. Okay, therefore the correct answer will be between 1 and 3. But to select the correct answer, we have to perform the calculation. But these two cannot be the answer, at least we can say, right? Now let me do the detailed calculation. Okay. H1 divided by H2. Here I assume that you know the formula for the maximum vertical height, which is velocity square sine square of angle divided by 2g. For H2, same velocity sine square of projection angle, which is 45 plus alpha divided by 2g. Okay, 2g cancel. Now sine square alpha minus 45 minus alpha, sine square 45 plus alpha. What we will do is that we will expand this sine square or sine 45 minus alpha with the help of the formula sine a plus b and sine a minus b. Okay, if we do so, this will be sine of a minus b, right? Sine of a minus b. So sine a cos of b minus cos of a sine of b. Okay, and then we have a square. Similarly, I will expand the denominator term, sine of 45 cos of alpha plus cos of 45 sine of alpha. Again, we have a square here, we have given the square. Now, cos 45, sine 45 both are equal to square root of 2. So I can take common, right? So this is square root of 2 and here we have cos of alpha minus sine of alpha, okay, square. Then again in the denominator, square root of 2 common, cos of alpha plus sine of alpha. We can cancel square root of 2, common square, right? And then let me expand cos alpha minus sine alpha in a plus b formula. So this will be a square b square minus 2ab, right? So a square plus b square minus 2ab. Similarly, this one, a square b square plus 2ab. Okay, cos square plus sine square equal to 1. So I will put 1 here minus 2 sine theta cos theta. What is this? Sine of 2 theta, right? Again, cos square alpha plus sine square alpha equal to 1. And this will be sine of 2 alpha, right? Therefore, this is the correct option, right? Let's move to the next question. All right, the next question talks about the conservation of energy and collision. Okay, it belongs to the collision topic. Nonetheless, the conservation of energy will be also applied here. Let's read the question in with the help of the diagram. According to the question, the description given in the question, it is like this. We have one bob A which is connected with the help of a light string whose length is r with the to a ceiling. Okay, and this is the horizontal plane, frictionless horizontal plane. Now I leave this bob A. As soon as we leave this bob A, it will come to the horizontal plane and then it will strike the bob B, which is at rest, which was at rest. And given that the mass of bob B is half that of the mass of A, okay, and therefore they will collide with each other, and after collision also they will move. The question is, after collision, what is the speed of bob A, right? And given that this is elastic collision, clearly mentioned this is elastic collision, and I assume that this is one-dimensional collision. How it is one-dimensional collision? Let me explain. Let's say this is bob B whose mass is equal to m by 2. Now as we release the bob A, just before collision it will come to the horizontal plane. Let's say this is A, okay. It should be very near to B, but still I have drawn it here. As soon as it comes near to B or horizontal plane, the velocity of A will be something. Okay, it will be something. And velocity of B before collision is 0 because it is at rest. Therefore, we can consider this to be one-dimensional collision. And after collision, both body A and body B will move with certain velocity. The question is, what is the velocity of body A? Right? Now, as a JEE aspirant, it is expected that you know the formula, you keep all the formula handy because you are appearing for the exam. Therefore, I will directly write down the formula for this V, which is equal to M1 minus M2, M1 plus M2, U1 plus 2 M2 U2 divided by M1 plus M2. Now, to calculate the final velocity of A after collision, we need to know U1, okay, and what is U2? U2 is 0, right? Initial velocity of B is 0, therefore this will be 0, right? To calculate this, we need now U1. How to calculate U1? Let's calculate. See, when we have a body and it is projected, or let's say it is released, not projected, it is released from a certain height, let's say h, then it will strike the ground with a certain speed. What is that speed? That speed is equal to square root of 2gh. How it is square root of 2gh? You can apply final velocity square equal to initial velocity plus 2gh and you will get the answer. Okay, you can get the answer, or you can also apply the conservation of energy. Okay, so you live a body from a height h, it will strike the ground with a speed of square root of 2gh. So if you know the vertical height h, right, you can tell what is the speed on the ground. Therefore, if I know this height h, then I can tell that before collision, when A arrives here, what is the velocity? That velocity is u1, right? That velocity is u1. So this u1 is square root of 2gh. Again, what is h not given? Let's calculate. Well, according to the question, this angle is 60 degree. Now to calculate h, I will draw some perpendicular. Let's say this is the perpendicular I have dropped here. This triangle that you can see, it is the right angle triangle, and therefore this arm will be equal to r of cos of 60. Why cos of 60? See, this from this triangle, base, this is hypotenuse and this is perpendicular with respect to this angle. Therefore, this will be cos 60. Therefore, this will be r by 2. From this point to this point, this is r by 2. Now, when the bob comes here, right, we can assume that this whole distance will be r. So if whole distance is r and this is r by 2, so this is another r by 2, which implies h equal to r by 2. Clear? Let's put the value of h, 2g r by 2 square root, which is equal to g. So this is the value of initial velocity of A just before collision. We will put it here. M is equal to mass of A, M2 is the mass of B, which is m by 2, m plus m by 2, and this is square root of gr. So this is m by 2, this is 3m by 2, and this is gr. So answer is equal to 1 by 3 multiplied by square root of gr. So this is the correct option, option A. Right? Now let's move to the next question. Well, this question is given from electrostatics chapter, and this question talks about the dipole which is placed in an uniform electric field, and the dipole is slightly rotated, okay, slightly rotated or given some push so that the dipole starts oscillating, okay. So let's try to understand the situation. If I try to draw the situation, it will be like this. Let's say this is my uniform electric field, and the electric field's value is equal to E naught I cap, okay. And what we have done is that, according to the question, we have a dipole. Let's say this is the dipole whose length is L, and it is given a slight rotation or slight push so that it start oscillating, Okay, and if it starts oscillating, it will have the time. It will have the time period. The question is, what is the time period? Right? It's a nice question. Now, when dipoles start to rotate, it will rotate about the center of the dipole. It means I can imagine one axis and then it will rotate. Okay, it will rotate. And let's say this angle is equal to theta, right? So what is the torque on the dipole? If it rotates, torque on the dipole is dipole moment multiplied by electric field, then sine of theta. Now, since it is simple harmonic oscillation, small oscillation, I can assume the theta to be small and thereby sine theta becomes equal to theta. I can write it like this. Again, from the dynamics, I can write down that torque is equal to moment of inertia of the system multiplied by initial angular acceleration. Right? Okay. But we have to calculate time period, right? What we are doing? See, to calculate the time period, we need the value of angular velocity, and angular velocity we can calculate. One of the way to calculate angular velocity is to calculate through angular acceleration, and angular acceleration can be calculated through the torque. So we have started our calculation here. We have written down torque's expression. From there we will calculate the angular acceleration, and then we will calculate the angular speed, and from angular speed we will calculate time period. That's the structure. I hope this is clear. That's why we have written the torque. Well, what is this? This is the momentum inertia of the system. The system has two particles. Let's write down. From the center of the dipole to the particle, the distance is equal to L by 2. So moment of inertia of each particle will be m multiplied by distance squared, but there are two particles, so 2. Alpha is written as omega square multiplied by theta. Okay, and then what is dipole moment? Dipole moment is amount of charge multiplied by dipole length, and electric field's magnitude is E naught, and this is theta. Cancellation, then 2m L square divided by 4 omega square equal to q multiplied by L E naught. L gets cancelled. If I do the calculation here, so if I take it this way, so this will be equal to ml omega square divided by 2 equal to q E naught, right? And then omega square will be equal to q E naught 2 divided by ml, or omega is equal to square root of 2q E naught ml. Then let's write down the time periods expression, which is 2 pi divided by t. Okay, two pi divided by t equal to square root of 2q E naught ml. So t will be equal to 2 pi square root of ml 2q E naught. So option 4 is the correct one, right? Let's move on to the next question. Dimension question. In every exam, dimension type of question used to come, but in JEE this time this kind of question also appeared very easy. Okay, I hope everybody got this question correct. Okay, the question is, which pair of physical quantities have different dimension? Okay, different dimension. Well, in option 1, torque and energy, right, both have same dimension, and their dimension is ml square t minus 2. Clear? Look at the option 4, pressure and Young's modulus of elasticity. They will also have the same dimension, m L minus 1 t minus 2. Angular momentum and the Planck's constant, they also have the same dimension, m L square t minus 1. But the surface tension and impulse, they have different dimension. The surface tension's dimension is m L0 t minus 2, whereas the dimension of impulse is m L t minus 1. Okay, they have different dimensions. So correct option is option number 2. Okay, so this is the next question. Again, assertion and reason question. Let's read this both. Let's read both the statement. First statement is the time period of a simple pendulum is longer at the top of the mountain than at the base of the mountain. This statement is correct. It is because if we look at the time periods formula, right? Time periods formula of the simple pendulum is equal to 2 pi square root of length divided by acceleration. Okay, and the acceleration responsible for oscillation is the acceleration due to gravity. And suppose this is Earth, okay, from the center of Earth, as the distance increases, the acceleration due to gravity will decrease and therefore time period will increase. Therefore, first statement is correct. Let's read the next statement. Time period of a simple pendulum decreases with increase of value with increasing value of acceleration due to gravity and vice versa. That is also correct statement. Time period decreases as the acceleration due to gravity increases, right? See, this is the mountain. Near the bottom of the mountain, the distance from the center of Earth to the bottom of the mountain is less, okay? And if I write down the acceleration due to gravity's formula, acceleration due to gravity is equal to g mass of Earth divided by distance square when we talk about the gravity outside the Earth, okay? So acceleration due to gravity is inversely proportional to the distance square, right? So less distance, more the gravity, okay? If gravity is more, at the bottom gravity is more, it means time period will be less, okay? But at the top of the mountain, the distance is more, which implies acceleration to be less and therefore time period is more. Both the statements are correct and reason is successfully supporting the assertion. Therefore, the correct option will be option B. Okay, option 2. Both statements are correct and reason is correctly explaining the assertion. This one also assertion reason question. Let's read the statements. First statement is emission of electron in photoelectric effect can be suppressed by applying sufficiently negative electron potential to the photosensitive substance. This is correct statement. We study this in experimental photoelectric effect. In a metal, in photoelectric effect, when we study the experimental part, as soon as the electrons come out of the metal surface, in the vacuum tube, what happens? When we apply the anode potential, okay, when we apply the anode potential, if we apply negative potential here, then this negative potential will try to stop this electron, okay, that is correct, right? Reason is negative electric potential which stops the emission of electron from the surface of the photosensitive substance varies linearly with the incident frequency. As a statement, this is correct. It is because the potential which is responsible to stop this electron or the current due to electron, photoelectric current due to electron, is proportional to the incident frequency. This is the formula for the stopping potential. It depends on the incident frequency. This is correct. But why this negative potential actually stops the electron, that reason is different. This is not this statement is correct, but this is not explaining the assertion. The reason why this electrons will stop, it is because the kinetic energy, maximum kinetic energy of electron becomes equal to the electrostatic potential energy supplied to the electron, okay? That's why it stops. Therefore, both the statements are correct, but R is not explaining assertion. Now go to the next question. This question is from electromagnetic induction, okay? Let's read the question. Question is, there is a coil whose area of cross section is A, it has n number of turns, okay? And the coil is moving with some angular velocity omega in a uniform magnetic field B about an axis which is perpendicular to B, always perpendicular to B. This situation is a common situation. Now magnetic flux is phi and induced EMF is E. And we have to calculate this magnetic flux and induced EMF at an instant when B is parallel to the plane of the coil. Let's try to imagine the situation. Let's say this is the coil which has n number of turns, okay, and let's say this is the axis of rotation, this is the axis of rotation, okay. Now in this situation, what is the magnetic flux formula? The magnetic flux formula is BA cos of theta, cos of theta. Okay, what is cos of theta? You see, suppose this is the coil, okay. Now coil, this is the plane of the coil, and what is the area vector of the coil? Area vector of the coil is like this, okay. Area vector is perpendicular to the plane of the coil. Now magnetic field is uniform and it is penetrating through the coil. Now the angle between area vector and the magnetic field is this theta, okay. Now as the coil is rotating, with constant angular speed, okay, therefore we can write down that this theta depends on time, sometime it will be 90, sometime it will be 0 degree, okay, it depends on time. And what will be the value of theta when B is parallel to the plane? Where, see, this is the coil, this is the plane of the coil. Now if the magnetic field is going parallel, right, this is the parallel direction. Now in this situation, area vector is perpendicular to the plane, but magnetic field is parallel to the plane, okay. In that situation, angle between magnetic field and the area vector is 90 degree, is equal to 90 degree. And in that situation only we have to calculate the flux and EMF. So this is the formula for the flux, and what is EMF? EMF is equal to minus d phi dt, okay. By the way, it has n number of turns, so we have to write n here. So minus NBA cos of, let me put omega t here, dt. So this is equal to, differentiation of cos will be minus of sine, minus will be cancelled, so n omega b a sine of omega t, right. Now what is the value of this phi and EMF when the value of omega t is equal to 90 degree? So phi will be equal to NBA cos of 90 degree, which is equal to 0, and E will be equal to NBA omega sine of 90 degree, which is equal to 1, and NBA will be, so this is the correct option, option 2, right. Okay, again we have a question from dimension. In the question, the velocity, expression of the velocity is given with respect to time, which is this one, and in the expression we have three constants, capital A, capital B, capital C, and we have to calculate the value of this product ABC, okay. To calculate the value of the product, we have to calculate the value of ABC separately first, right. So let's start. First, when you look at the expression, this V equal to AT square plus this much, we will apply the homogeneity of dimension, and from the homogeneity of the dimension we know that dimension of velocity and dimension of this AT square will be same, right. And therefore what will be the dimension of A? Let's put the dimension of velocity. So A will be equal to L t minus 3, okay. Now let's look at C plus T. This C and T, they are added, therefore the dimension of C and dimension of T will be same by homogeneity. So dimension of C will be equal to T only. This is also done, right. Now come to that B. How we will find the dimension of B? This whole expression, right, BT divided by C plus T will have the dimension equal to V, okay. So dimension of V is equal to BT plus C plus T. Now dimensionally this is B, this is T, C and T, they have same dimension, so dimensionally I will simply write T here, and dimension of this T is T, and the dimension of velocity is L t minus 1, T cancel, So B's dimension is LT minus 1. Now let's take the product of ABC. So A, B and C, if I take the product, so this will be equal to LT minus 3 multiplied with T multiplied with LT minus 1. So this will be L squared T minus 3. Since we do not have M, we will simply put M power 0. Therefore, the option 1 is the correct one. Okay. Let's move to the next question. Alright. Again, question from electromagnetic induction. Now, in this question, what do we have? We have two coils, one in primary coil and the secondary coil. In first coil, the electric current is I1, and in the second coil, electric current is I2. Okay. The self-inductance of the first coil is given L1, and mutual inductance of the coil 1 with respect to coil 2 is M12. And we are supposed to calculate the value of induced EMF in coil 1. Okay. So whenever we have a coil and let's say a current is flowing and the current is a varying current. Therefore, in this varying situation, it will cause the self-induction, and the EMF due to self-induction will be equal to minus L d I1 dt. So current in the coil with its change with respect to time multiplied by L is the induced EMF. Now, if you place one more coil in the vicinity of another coil, and in the second coil, if you keep one more current which is varying with time, it is also varying with time, then according to the principle of mutual induction, the magnetic flux due to this coil 2 will penetrate into coil 1, and as the electric current changes in coil 2, it will cause some induced EMF according to Faraday's law in coil 1, and according to mutual inductance, the amount of induced EMF in this coil will be equal to mutual inductance of 1 with respect to 2 multiplied by rate of change of current with respect to time. The question is, what is the amount of EMF induced in this coil? And we know that there are two EMFs, this one and this one. And EMF is a scalar quantity, we don't have to think about the direction, we will simply add them. Therefore, if we add them, we will get this one. Let's move to the next question. Alright, we have one question. Let me explain the question. You pause the video and read the question, and then only you see the solution, okay? Or solution or discussion, whatever. According to the question, we have two media. One media is N1, one media is N2, okay? N2 is the denser medium, N1 is the rarer medium, and therefore the critical angle for this pair of media is equal to theta 1c, okay? Critical angle is theta 1c. Now, if I replace, according to the question, if I replace this N2 with N3, if I replace this N2 with N3, the critical angle becomes equal to theta 2c, okay? And we have to calculate the value of this theta 1c, okay, theta 1c. Now some data are given, and this question will be a bonus question, okay? Why? You see, some data are given, and according to NTA, option 4 should be the correct answer, but many coaching centers have solved this particular problem and got different answer, and their assertion is that since the calculated answer is different from the options given, therefore this question is incorrect, their solution is correct. But let me tell you, this question will not have a solution, okay? It is because all the answer given in the option are incorrect, and the solutions provided by all the coaching center are also incorrect. It is because this question is conceptually misframed. Let me explain you why. You see, two statements are given, okay? In one statement, N3 is more than N2 more than N1, obvious, right? And in another statement, the value of the critical sign of critical angle, okay, sine 2c and sine theta 2c, sine theta 1c is equal to half, okay? These two statements are given. Now look here. What is the formula of critical angle? Critical angle is equal to refractive index of the rarer medium divided by refractive index of the denser medium, right? Now if the denser medium's value is more, then sine of the critical angle will be definitely, I'm sorry, if the denser medium has more refractive index, then sine of critical angle will be less, yes or not? And in this case, this will be equal to n1 by n3 and this will be equal to n1 by n2. Now look, since n3 is more according to this statement, right? Therefore, this sine of theta 2c should be less and this should be more. Therefore, this subtraction cannot have a positive number, it should have a negative number. So these two statements are contradictory to each other. Therefore, question is a misframed question. We cannot do the solution. Okay, we can of course proceed and do some calculation. We will obtain some answer also, right? But that is not conceptually correct. Okay, so this will be a bonus. So this is the next question. Let's read the question. So according to the question, we have a long wire of radius A. Okay, the wire is in the shape of the cylinder and the radius of the cylinder is A, and the electric current I is flowing uniformly throughout the cross section of the wire. Now we know that current carrying conductor is a magnet, okay, and therefore it can have magnetic field. The question is, what is the distance at which the magnetic field will be half of the maximum possible magnetic field? Let me explain you with the help of diagram. Let's say this is the wire in form of the cylinder. This is the axis of the cylinder. Let's say the radius is A, and electric current I, which is uniformly flowing throughout the cross section. Now, what is the maximum possible magnetic field? First of all, you see, it can have magnetic field everywhere. We know that maximum magnetic field will be on the surface of the conductor, which is equal to mu naught I divided by 2 pi A. Okay, right? Now, there will be 2 points, one inside and one outside the conductor, where the magnetic field's value will be half of the maximum values. Okay, let's say this is one point which is located inside and this is a point which is located outside. Okay, the inside point is located, let's say, at a distance r1 and outside point is located at a distance r2. So if the magnetic field in these 2 points are equal to half of the maximum magnetic field, then what is the value of this distance r1 and r2? That's the question. Okay, so first we will start with the inside. When we talk about the inside point, what is the value of the magnetic field at a point inside? It is equal to mu naught I, distance from the axis, divided by 2 pi radius square. And according to the question, this should be a point which has magnetic field half of the maximum value. Okay, therefore mu naught I r1 2 pi a square. Let's put the value of the maximum magnetic field, which is mu naught I 2 pi divided by a. 2 pi gets cancelled, mu naught I gets cancelled, right? And then 2 pi a square, mu naught I r1, mu naught I get cancelled, 2 pi gets cancelled, 1a will be cancelled with this one, and therefore this a will go there, a divided by this 2 equal to r1. So r1 is a point inside the conductor which has magnetic field half of the maximum value at a distance a by 2. This is for the inside point. Now we have to calculate the distance for the outside point. Okay, for outside point, let's calculate here. For outside point, the magnetic field's value is equal to mu naught I divided by 2 pi r2. Now this magnetic field is half of the maximum magnetic field, right? So mu naught I divided by 2 pi R2 half mu naught I divided by 2 pi R2. Okay. So this is equal to mu naught I 2 pi R2. Sorry, this is A. This should be A. Now 2 pi gets cancelled. Mu naught I gets cancelled, right? So here we have 2 multiplied by A equal to 1 by R2. So it will imply R2 equal to 2A. Okay. So this distance R2 is equal to 2A. So outside point is located at a distance, inside point is located at a distance A by 2 and outside point 2A. So this is the answer.